everyone, welcome to Math Dive in 5. This is for adding and subtracting within 10 for first grade. My name is Alyssa Foss and
I'm Shannon Young.
So let's go ahead and get started. One of the biggest ideas in this unit is going to be adding and subtracting, and you want to make sure you consider what students have learned in the past and where their learning is going in the future. So thinking back towards kindergarten or even pre-kindergarten, students began to explore with addition and subtraction within 10. And then, especially in kindergarten, working with some sort of a reliable strategy for adding and subtracting, whether it be counting on, using their fingers or blocks, or drawing pictures. And then it's important to notice that kindergarten students are not expected to be able to recall addition facts automatically. And then in first grade, you are still exploring, but now you're pushing that to 100. So you're going to be working with adding and subtracting within 100. And your first graders are going to be looking for a reliable strategy that will help them add and subtract within 20. And then in terms of fluency, we want first graders by the end of the year to be able to recall addition and subtraction facts to 10 only. And again, that is by the end of first grade. And then moving into second grade and beyond, students continue to explore addition and subtraction to the 1,000, and then also adding and subtracting with reliability within 100. And their fluency piece in second grade will be to recall addition and subtraction facts to 20. So as you can see, it really does build on each other year to year. So that's important for you to know in terms of differentiating for students in your classroom.
So I can see how kindergarten and first grade really are that foundation for that big jump in second grade and the higher grades.
Exactly, yes. If they get a really good K-in-1 foundation, then the second grade will just be continuing on with that understanding. So it's also important to understand that throughout the grades, kindergarten through second grade and beyond, students are working with different types of word problems.
There's different types of word problems?
There are.
Oh, I didn't know that.
And also, when solving and working through problems, we want students to be able to use the CRA model, thinking about how do I use these concrete tools, how can I represent it visually, and then eventually ending up with an abstract representation.
You can kind of see how CRA connects to the Explorer, the procedural reliability and the automaticity. Really in that Explorer, we're really focused on the concrete, and then we move into the representational and that procedural reliability. And then with that automaticity, I don't need those anymore because I've memorized those facts by then.
That's right, and there isn't a rush to get there. So we're going to start with having you do some math. You are going to do the apple tree task in 3 ways. So you're going to see 3 scenarios. You're going to pause the video and represent each of these scenarios using whatever method you'd like. You could use tools, you could use visual models or pictures and or equations. But when you're finished, take a minute to look at and compare your different models, and then push play and come back. All right, so hopefully you had a chance to solve those 3 tasks so that this part will make more sense to you. So here we're getting into the different problem types. The tasks that you solved were all add to problem types. This is a typical type of problem that we would see, but you can have an add to problem in 3 ways. Where the result isn't known, where the change is unknown, and where the start is unknown. And the important thing when you're doing these types of problems is that there is some sort of an action, like the apples falling from the tree, that goes with it.
Okay.
And then if you think of the inverse, the take from is the opposite action. So there's still an action, but now instead of adding to, we're taking from. And so you'll want to help students see the relationship there. And then put together is similar to adding to, however, there may not be an action involved. And we'll look a little bit more at that in a minute. And then your comparison problem type is really interesting because students may choose to use subtraction or addition depending on how they're making sense of the problem. So let's start with the first problem type, which is adding to. We want to make sure that students are starting with concrete, like we said. So they're going to be using any kind of concrete object or counter, and then moving towards some type of a representation. This is a bar model or a number line or just a picture. And then eventually being able to connect those to the abstract numbers and symbols that we typically see. Does that make sense?
It does, yeah. I can see how it would make sense for students to start with the tools and then maybe even labeling the numbers with the tools and then moving into using a picture and connecting the pictures to the equations.
Right. Thank you for saying that. And it's also really important that the scenario, whatever the scenario is, in this case it's about apples, but they're connecting the scenario to their tools or to their visual model or equation and keeping those connected.
So I should be able to see that there are the 3 blue counters are the 3 red apples in the first scenario, and the red counters are the green apples.
Right. So it's all about representation and which represents what. And then one more thing to think about is with this problem type, when you're thinking about the different scenarios, you want to think about what is the same and what's different about them, because they're all about apples. They're all about red and green apples.
They were, yeah.
So on first glance, a student might think that it's the same scenario.
Yep, it was really cool solving all 3 of them because the first one I knew I had the red apples and I knew I had the green apples. The second problem, I started with red apples, but I didn't know how many green apples I had. And then the last one, I didn't know how many red apples I had, but I knew how many green apples I had. So it was really cool to solve all 3 together.
Right, because you're able to use one problem type to solve another. Absolutely. And it's also important to consider how students are connecting their representations. So students are able to take a visual model and connect it to someone else's concrete tools and connect it back to the equation and the scenario. So they're seeing how all of the different ways to represent the math are related. So then we have the take from problem type, which is the opposite of the add to. And so as we see here, it's going to be important for students to identify where the unknown is. So the unknown is going to be in different positions, but students need to be able to identify where is the unknown in the word problem? Where is the unknown in my concrete representation or in my picture? And then eventually, where does the unknown go in my equation? And again, being able to connect those pieces. Hi everyone, welcome to Math Dive in 5. This is for adding and subtracting within 10 for first grade. My name is Alyssa Foss and
I'm Shannon Young.
Finally, we're going to look at a put together problem type. And the difference between put together and add to is the add to problem type, if you remember, there was an action. The apples were falling from the tree and then they were on the ground. In this case, there's not necessarily an action. So there are some apples and they're in a basket. They're just there. And the problem is to determine how many are total or how many are red or how many are green. So for a total unknown problem, we're looking at being able to identify, I have the 2 addends and I need to find the total.
So it seems like this problem type might be a little bit harder than the first 2 problem types because there's no action.
It usually is for students. It's harder for them to visualize. So the concrete tools are going to be super important when it comes to this problem type for sure.
Okay.
And then that being said, they're either finding the total or the missing addend. It's also going to be important for the next problem type to represent it with concrete tools and connect to the equation. And this problem type is comparison. And this is probably the most difficult problem type that students will encounter. And as you see here, the difference is that there's an addition and a subtraction equation listed here because students are going to use one or either or both, depending on what makes sense to them. And the biggest part is for you to ask them questions about the unknown. So where is the unknown in your representation, and how does that match to your equation, whether you added on using addition or whether you found the difference through subtraction? Can you identify where the unknown is in the context of the situation?
Wow, that's so interesting. I didn't realize you could use addition or subtraction to solve one problem.
And what's really cool about that is you'll notice a lot of first graders will tend to do the adding on before they can make sense of finding the difference with subtraction.
Mm. So it's important to show both ways.
Yes, yes, absolutely. You don't have to force kids to do both ways, but if they can see both ways and connect them, then that will help them understand for sure. So finally, just to reiterate the importance of the CRA. So we've got concrete, representational, and abstract ways of thinking. And we want to make sure no matter what strategy students use, they are connecting it back to the context of the problem.
Right. So when I see the equation 3 plus 5 equals what, I should be able to say there are 3 apples and 5 apples.
Right. And so you should be able to also point to where those 3 apples and 5 apples are with the models that you've either drawn or created. And then it's going to be really important for students to connect their own understanding to others. So if I used a concrete model, I want to make sure I'm connecting that understanding to someone who used a visual model or wrote an equation so that they can make that progression. So that's a lot.